Welcome to iTTV for Form 4 Physics. The title of this lesson, Linear Motion. We're now entering into the second chapter of our physics. The first topic we want to look at is called linear motion. Now, in linear motion, what we're going to learn is a few of the more basic values and quantities that we use in physics that you will find very, very important because they are the basis of a lot of our physics. We're going to learn about things like distance, displacement, speed, and velocity. And we need to understand what each of these mean and how we can find them or calculate them through equations. Linear means straight. Motion means movement. Movement in straight lines. So when we talk about linear motion, we're talking about movement in a straight line. Now, when we say straight line, please don't think it can only mean from left to right. A straight line could be from left, straight to the right, straight upwards, straight downwards, straight backwards, straight at a diagonal. So as long as the motion is straight and there is a direction, we call it linear motion. We are not going to be dealing with circular motion. That is for a different time. Distance. The total distance moved by an object. Distance is a scalar quantity. So when we talk about distance, what we're talking about is how far you have moved or the total length that you have moved. It doesn't matter in what direction. As long as you moved in a straight line or straight lines from where you started to where you finish, we want to know the total length you actually moved. That is distance. Remember from the last chapter, we talked about these values scalar and vector. The scalar quantity has a magnitude but no direction. Because we don't care in which direction you moved, just the total length, distance is regarded as a scalar quantity. Displacement. The total length moved by an object from the point of origin in a particular direction. Direction is based on compass directions, example north, west, southeast, etc. Displacement is a vector quantity. So when we talk about displacement, what we're really talking about is moving from point A straight to point B. We don't care whether in the movement we went up, down, left, up, and then reached B. The value that we are looking for is just the value from A to B. That is what we want. That is displacement. But we also need to know the direction of displacement. What we need to know is whether displacement was to the left or to the right or to the north or to the south. So because we need to know a direction value, therefore we count or we quantify displacement as a vector. Remember, vectors have a magnitude and a direction. Now that we've had a look and taken into account both distance and displacement, let's go up to the board and have an example of how to calculate distances and displacements in different situations. So first, let's take a situation. Now, let's say, for instance, that we have a house over here. From the house, over on the left-hand side here, let's say that there is a bus stop. And then over on this side, let's say that there is a provision shop. Now, the distance from the house to the bus stop, let's make this 50 meters. And the distance from the house to the shop, let's make this 150 meters. Understand that we are starting from the house. The house represents what we call the point of origin. So this is our origin. Let's say that we leave the house and we go to the bus stop. So we went from the house to the bus stop. Then from the bus stop, we walked to the shop. Like so. Now, the total distance traveled is from the house to the bus stop and from the bus stop to the shop. So the total distance traveled is going to be $50, which is the distance from the house to the bus stop, plus 50 from the bus stop to the house, and then from the house to the shop, which represents 50 plus 150. Altogether, 50 plus 200 gives you 250 meters. That is distance. We don't care about the direction, we just want the total length moved. So you moved 50 meters this way, 50 meters back, and then another 150 meters in this direction. That is distance. Displacement, however, is different. Displacement is just the difference between where you started and where you finished. Now, you started at your origin. This is where you started, at this point. And where you finished was at the shop, over here. So all we want is this distance, nothing else. So your displacement is only 150 meters. So your displacement equals just the final distance that you moved from your origin to your new place. But you need to be able to calculate it. So what we do is, we do a very simple calculation, which is the total distance to the right minus the total distance to the left. So, the total distance to the right minus the total distance to the left. Now, to the right, we are moving from here all the way to here, which is 200 meters. The total distance of movement to the left is only 50 meters. 200 minus 50 gives you 150 meters. So please understand the difference between distance and displacement. Now, what about if the direction is not in a linear motion type situation? Meaning, we're not just moving to the right or just moving to the left, which is quite easy because all we do is distance, we add everything up, and with displacement, everything to the right subtract from everything to the left. What if your motion changes? What if you're going from left to right and then suddenly up to down? Let's have a look at an example such as this. What if I started at point A, and from point A I moved 2 meters to the right to point B, and then at point B I moved again, but I moved downwards or in a southerly direction, like so. Now, if I move like this downwards, let's say that in this instance, I moved 3 meters to point C. Now, in this case, to do the distance, we just keep to our normal practice, which is just add up the total lengths that were traveled. So distance would equal 2 meters, which is the movement up here, 2 meters, plus the movement downwards, which is 3 meters. So it will just be 2 plus 3, which equals 5 meters. Nothing too complicated about that. But what about the displacement? Now, really, what we've done is we started here and we finished here. So the displacement is actually a direct line connecting these 2 points, like so. That would represent your displacement. How do you calculate that? Well, you can calculate that by using simple Pythagoras theorem. And basically, you would get a calculation something like this. Displacement would be, displacement symbol is S. So S squared equals this distance up here, 2 squared, this distance here, plus 3 squared, which equals 4. 2 squared is 4, plus 3 squared, 9. And to find S, it would be the square root of this. So if we did a calculation such as that, we would get our answer. 2 squared, 4, 3 squared, 9, 4 plus 9 gives you 13. Find the square root of 13 and you would get your answer. So please understand how to do it. With straightforward lines that are moving left to right, it's the total movement to the right subtracted from the total movement to the left. That would give you your displacement. But if you have a situation where you're moving and changing direction, then connect the 2 points, the point of origin and the final position, and then using Pythagoras theorem, find the line length using a squared plus b squared equals c squared. Question: calculate total distance. Now, in the diagram you have, we're using a similar question to the one over here. We want to calculate the total distance. Remember, distance is just add up all the length. Let's have a look at the answer. Answer: 2 plus 1 equals 3 meters. So your total distance is 3 meters. Calculate the total displacement. Pythagoras method. So we've got the same question like here, but we want the displacement. Remember, the displacement is your distance from your origin to your final position. So remember, just use Pythagoras, which is a squared equals b squared plus c squared. So let's have a look at the answer. 2 squared plus 1 squared equals 4 plus 1 equals 5. Square root of 5 equals 2.24 meters. Okay, which should be an easy calculation if you use your calculator. Now let's try a slightly trickier question. Calculate the total distance traveled. Now, even though we're going up, down, left, right, and all of these, remember, keep it simple. Distance is the total length that you have gone through. So just add everything up. The answer: 5 plus 7 plus 5 plus 10 plus 10 plus 10 plus 10 equals 57 meters. work out the displacement. Now, this one is a bit trickier, but look at what you have. What's important here is connect P to Q. You know where P is, that is where you started, and you finished at Q. Draw a line connecting these two. Now, calculate the length of that line. Don't worry about all the other motion. All we want is the straight line connecting the origin and your final destination. Have you drawn the line? Good. Now work out those distances, add them up. Have you done it? Let's check the answer. The answer is 7 plus 10 plus 10 equals 27 meters to the left. So please remember, what is very important here is that you also put in the direction. Speed is how fast you go. Velocity is how fast in a given direction. Now we want to have a look at the two quantities, speed and velocity. Speed is how fast we are going, but we don't care in what direction. Velocity is how fast we are going, but in a particular direction. So this is where speed and velocity are slightly different to each other. Speed. Speed is the rate of change of distance. Speed equals distance traveled over time taken. Quantity, scalar. SI unit, ms -1. So now you've got to remember 2 or 3 very important things. Firstly, the definition. It is distance per unit time, which means the rate of change of distance. Please remember, anytime we divide a value by time, it becomes a rate of change. So it's the rate of change of distance. Because we don't really care about the direction we are traveling, because we're using distance, speed becomes a scalar quantity. Finally, the SI unit. We are dividing distance over time, which is meters over seconds, which gives us ms -1. Velocity is the rate of change of displacement. Velocity equals displacement over time. Quantity, vector. SI unit, ms -1. So velocity is defined as the rate of change of displacement. Once again, because we're dividing by time, we call it the rate of change. The formula is displacement over time. Because we're using displacement, which is a vector quantity, velocity becomes a vector quantity. The SI unit is displacement, meters, over time, seconds. M over S gives us ms -1. Uniform speed. Speed that remains the same in magnitude regardless of its direction. A steady speed of 10 meters per second means a distance of 10 meters is traveled every 1 second. Uniform velocity. Velocity that remains the same in magnitude and direction. A steady velocity of 10 meters per second means a displacement of 10 meters is traveled every 1 second to the left. So understand this terminology, uniform. When we say uniform velocity or uniform speed, it means the speed or velocity does not change. If I say it has a uniform velocity of 1000 meters per second, it means it keeps moving 1000 meters every second. If I say non-uniform, this would mean that the velocity or speed was constantly changing. An object has a non-uniform velocity if the direction of motion changes or the motion is not linear. The magnitude of its velocity changes. Can have increasing velocity equals acceleration, decreasing velocity equals deceleration. So when we talk about non-uniform motion, non-uniform velocity, please understand it means that the velocity is changing. When our velocity changes, we can have acceleration or deceleration. If you go faster, it's acceleration. If you go slower, it is deceleration. If you are not moving, we say you have zero velocity. So it means that the object is either stationary or we say sometimes at rest. Now let's go up to the board and have a look at examples of how to calculate speed and velocity. Now let's use our two examples here. In this first example, let's say that the time taken to go to the bus stop and then to the shop was 10 seconds. Okay, so now we have a time. The first thing we want to do is we want to calculate our speed. So the formula for speed is distance over time. Now, with physics, we always pull our information to the side. We call it extracting the information when we have to do a calculation. The distance that we moved, distance, was 250. The time, 10 seconds. So this means our speed was 250 over 10, which equals 25. Remember the units? ms negative 1. So that's how we would calculate speed. We use the distance quantity. What about velocity? Velocity equals displacement over time. Once again, let's pull our information out to the side. Displacement, we use the symbol S for this. The displacement we calculated earlier was 150. The time, still the same, 10 seconds. Which means that we get a calculation of 150 over 10, which equals 15, same units, ms negative 1. So you'll notice that both the values are quite different. Because speed generally takes distance, which is normally a larger value, well then you're going to get a larger value for your speed. If you move in different directions, your displacement becomes less than your distance, which in this case causes the velocity value to diminish. Question: an object is moving with constant speed of 5 meters per second. The object A, it is accelerating. B has zero acceleration. C moves with constant speed. So if we say that an object is moving with constant speed, that means the speed is not changing. If the speed doesn't change, normally an object is said to have no acceleration. Now, based on that, what would be your choice of answer? Have you selected one? Let's check. Answer B has zero acceleration. Another question. Which of the following is true regarding the motion of an object having zero acceleration? Remember, if you have zero acceleration, what can you say about the velocity? Is the velocity increasing, decreasing, or is it uniform? A, the object is not moving. B, the object is moving with uniform velocity. C, the object is moving with minimum velocity. D, the object is moving with maximum velocity. So remember, we are at zero acceleration. How do we explain this in terms of velocity? Have you selected an answer? Let's check it. Answer B. The object is moving with uniform velocity. Question. The diagram below shows the path traveled by a car from P to S. What is the displacement of the car? A. 3 kilometers. B. 4.2 kilometers. C. 8.2 kilometers. D. 9.0 kilometers. Now in this question, you need to do a bit of a diagram. You need to draw it out. Look at where you started and look at where you've ended. So I'll just quickly describe this on the board for you. Your diagram looks something like this. You start here, you moved like this, you moved downwards, and then you moved backwards. Remember, with displacement, the question is asking for displacement. We want to go from the start to the end, which means that you should be connecting point A to point B, your start to your finish. You need to calculate that. So make yourself a triangle and use Pythagoras theorem. You've got to be able to understand these things. When you see questions like this, understand, oh, I'm changing direction, I've got to use Pythagoras. If it's straightforward left and right, remember we just use the left minus right or the right minus left method. So quickly do your Pythagoras, work out the answer. Have you done it? Let's check the answer. Answer B, 4.2 kilometers. So remember, for the first topic that we've looked at in this chapter, topic 2.1, remember you have to understand distance and what it means. Displacement, what does it mean? You need to know speed and the formula for speed. You need to know velocity and the formula for velocity. You need to relate speed, displacement, velocity, and distance to the idea of scalar and vector quantities. You've got to know this basic material from this topic. Print out this slide and make sure all of this information is put down and keep it for yourself in a little folder. This is the basic material that you need to know. This is what they're going to ask you about in examinations. This is what you must know when we talk about distance, displacement, speed, and velocity. That's all the time we have for this lesson. Thank you for watching iTTV.